So section 1.4, question number 4, we know the last term, we also know the first term, and we can easily solve for r, right? So here's the formula that we want to use. We want to use the formula that includes the last term, t of n. Okay? We didn't use that yesterday in the lesson as an example, but I mentioned it at the very end. This will actually help you do some questions a little bit quicker. You can use the other one, but you have to find n first with the other formula. So with this one, it's a little more straightforward. So I've already kind of given this a start. I've identified r is 3 divided by 9, or 9 divided by 27. It's t of n divided by t of n minus 1, right? So any point in the series, you can just take a number, divide it by the number that comes before. So we get 1/3. The first term is 27, and the last term is 1 over 243. So what we do now is we put all these values just into this sum formula, and you work it out. So S of n is going to be equal to 1/3, okay, times 1 over 243 minus 27. That's what goes on top for the numerator there. And then divided by 1/3 minus 1. All right. So algebraically speaking, right, we want to do this multiplication first here. May as well do that. So 243 times 3. And interrupt me if you think I've got something wrong here. 243 times 3. So that's 1 over 729 minus 27. All over 1/3 minus 1, that's 1/3 minus, we may as well change that into a fraction over 3, so we can have a common denominator. Okay, we could do that to the top as well. Your calculator might be able to do 1 over 729 minus 27. If you want to do that, that's fine. How we would do this, if your calculator wasn't going to do everything for you, is you would write 27 as a number over 729 to get a common denominator to subtract fractions. So you could do that. You could do 27 times 729, and this would be a really huge number, but it would be this number over 729. That's what 27 is. 19,683 over 729. Okay? So I'll just change that here and move that into a fraction. So that was 19,683 over 729. You see how I'm getting common denominators. And again, if you wanted to use the fraction function on your calculator, then you just go right ahead. So if we do the top one first, then we have negative 19682 over 729 over, what's 1 minus 3? That's negative 2 over 3, negative 2/3. Okay? So I'll just move up here. When you divide by a fraction, it's this. The shortcut is to flip that fraction over and then multiply it. So this is what we're going to do. We're going to do 19682 over 729 times negative 3 over 2. See how we flip this fraction around? And you can flip and multiply. Okay? Might be a good idea to get your calculator to help you with this one now. So let's do 19682, okay, divided by 729, and you can use decimals if you want. You don't have to. I think if it asks you for exact values, then you have to keep the fractions, okay. But if you want to let your calculator do this, that's totally fine with me. So I just did this as a fraction, the first one, and then I'm going to multiply by negative 3. Equals, and then I'm going to divide by 2. So times negative 3 divided by 2. And you should get about 40.497 or 40.5. Okay? Again, that's fine. As a decimal, you could pump these decimals into your calculator, multiply them, and then it should give you the decimal, which I think, now I have this written down over here somewhere, 9841 over 243. So that's what this turns out to be. 9841 over 243. Okay? So that's what you get. That's the decimal approximation, and that's your fraction form. Okay, so that's number 4. Someone asked about number 5 as well. I think I heard a number 5, did I not? So I'll just set up number 5 for you. You're going to want to use this sum formula right here because the sum that they give you is 33. So that's actually this right here. That's 33. T of n right here is 48 and r is negative 2. So you've got negative 2 times 48 minus, you don't know T1, so that's what you're looking for. What's the value of the first term? All over negative 2 minus 1. So you can manipulate this equation. I'll show you quickly how to do that. This is a negative 3 on the bottom, so let's multiply both sides by negative 3. So that gets rid of that, and it brings it up over here. Negative 2 times 48, that's negative 96 minus t of 1. Oops, not I, t of 1. Weird. All right, and so let's see, negative 3 times 33, that's what? Negative 99. Negative 99. Let's add 96 to both sides. And that's going to give us negative t1. So negative 99 plus 96 is negative 3 equals negative ti, or t of, why do I keep saying I? T of 1. And so 3 is t of 1. Because you can divide both by negative. They're both negative, the same as being both positive. So is that the answer there for number 5A? Yes. Okay, good. So that's how you do 5A. And you can use that sort of method for C. So I don't have the textbook up here just yet this morning, so let's do that real quick. And let's go page, what, about 58 or so. Question number 10, you said? So is this the right section? Is this the 10 right here? Okay. All right, so question number 10 says a tennis ball is dropped from a height of 20 meters. It bounces to 40% of its previous height on each bounce. So it starts at 40 meters, and after the bounce 1, bounce 2 comes up to 40% of its original height. So we won't do 6 right now, but let's do, put 10 up there. Okay. So if we want to just do some sketching here, this might be a good idea. The ball here is at 20 meters, right? It's going to bounce and come back up to only 40% of its previous height. So this is going to be 20 meters times 0.4, right? Right? So what's that, 8? That's going to be like 8 meters. Okay? And so on. So that keeps happening. Bounce, 40%. Bounce, 40%. Okay? So the total vertical distance traveled is made up of upward bounces and downward drops. So this is interesting. Draw a diagram to represent this situation. What is the total vertical distance the ball has traveled when it hits the floor for the 6th time? Express your answer to the nearest tenth of a meter. Okay, so this one is a bit tricky because we're talking about total vertical distance that it's traveled. So that is the total distance from the drop plus the bounce up plus the bounce back down plus the next bounce up and so on. So this one's a little tricky. So you can see in this first stage, and I'll just maybe highlight this right here, that first stage there in the blue, that's going to be 20, right? Then it's going to go up 8. Then it's going to go down 8 because it's got to get back to the floor. Does that look right? 8, 8. So then what's 40% of 8? 3.2. Someone help me? 3.2 plus 3.2 because it's got to go up and then back down. So what's 40% of 3.2? 1.28? Somebody help me? Is it 1.28? Thank you. And after, what are we going to do? 6 bounces? Oh boy, right? After this, when it hits the, what is the total ball has traveled when it hits the floor for the, okay, so when it hits the floor for the 6th time. All right, so here's the first time, second time, third time. We're only at the third time. We're at the fourth time, and so on. Fifth time, up 6. So that's pretty crowded now, but that's what we have to. We have to do this one plus this one plus this one plus this. So there's going to be lots there. Now, we could take a look at what we've got so far and see if we can come up with some kind of pattern. I'm thinking like this is not a geometric sequence right now, is it? Because we've definitely got an R value here, but then it's a different R value here. Right? So what about this? I don't know, I haven't tried this out yet, but what if we did 20 and then we grouped these two together? And then we made that 16. And then we grouped these two together and made that 6.4. Is that right? Boy, I don't know if that's going to work either. 2.56? Boy, I don't know if that's going to help us either. Is that geometric or not? Whoa, I don't know if it looks like it. So I'm going to leave it there. Actually, I'm not going to do the whole thing with you. I just showed you the diagram, and I'm going to get you to see if you can. Now, if you want to just add up all the numbers and just keep going like we've been doing, I guess that's fine. Could you find a pattern and throw it into one of the formulas we've been using? Maybe, but that's all I'm going to give you for number 10. Okay, and I might give you a few more minutes here just to kind of see if you can finish it off for those of you that are close. But that's all I'm going to give you for number 10, and maybe I'll show you the completed answer in a few minutes. I probably will do that. I'll show you the completed answer in a few minutes, and you can see if you've gotten it. But take it from there and see if you can get this answer. Okay, hopefully you've got a chance to look at number 10. Now, if you just added up all of the numbers after the, up until it hits the floor for the 6th time, that's fine. I did encourage you, if you did that, to try and figure out how you could use the formula. So this is what you want to notice. As I mentioned, starting at 20 is T1. This is not a geometric sequence, right? But if you start at 16, the rest of this would be a geometric sequence because you're multiplying by 0.4 each time. So you actually can use the sum formula here. We're going to use this one right here. And if you just keep in mind that at the end you have to add the 20 meters for the first bounce, then you'll be okay. So watch this. It goes like after the first bounce, so T of 1 is going to go 8 plus 8, so T of 1 is 16. After the second bounce, it's going to go 3.2 plus 3.2, so that's the second bounce, and so on. Third. So after the second, it's here, third, fourth, fifth. So we're looking for the fifth T of 5, or S of 5. Okay. So again, one bounce gets us to 2, two bounces gets us to 3, and so on. So if you were to use this formula, you should get 26.3936. And of course, if we add that to our original 20 meters, this is the answer that you should get. Okay? So those of you that put up your hand earlier to get that, is this the answer you got? Yes? No? All right. So that's number 10. And let's leave that up there for a few more minutes for you.